Let's talk about how to do this lever lab. You will need a stack of pennies, some tape, a pencil, and a paper clip. Tape together 15 pennies. If you don't have that, you can use a different coin instead. Unfold a paper clip and tape it to the pennies so that it acts like a hook. The pencil will be your lever, your fingers will be the fulcrum where it pivots, and your pennies will be your load or your resistance. So for a first-class lever, remember free, fulcrum, resistance, effort. First, F, fulcrum. So the fulcrum goes in the middle of a first-class lever. Draw a triangle to represent the fulcrum or the pivot point. Draw a box to represent your load, and draw an arrow to represent your effort. So pinch the pencil in the middle, that's your fulcrum. Put the pennies on the pencil as your load, and here use your other hand to be your effort. So here you'll notice that you use your effort to lift the pennies. Move the effort force closer to and further from the fulcrum, which decreases the effort force. So, is it easier to lift the pennies if you lift close to the fulcrum or far away from the fulcrum? If you can't tell, you might need to get a longer stick instead of a pencil. But it's actually easier to lift if you hold way out here than if you hold close to the fulcrum. Therefore, moving the effort force further from the fulcrum helps to decrease your effort force. Now this time, move your load closer to the fulcrum. Is it easier or harder to lift? It is easier to lift, you have less force when the load is close to the fulcrum. So, can a first-class lever make a load easier to lift? Yes. But can a first-class lever make a load harder to lift? Well, if you move your fulcrum way out here and your load way out here, and your effort is here, that's much harder to lift, isn't it? So yes, it can actually be harder to lift an object instead of easier with a first-class lever. Or if it's perfectly balanced, the input force and the output force can balance out if your fulcrum is directly in the middle. Because however much these pennies weigh, that's the amount of force needed to lift them when it's nicely balanced out, like a seesaw. So if a machine makes an object easier to lift, its mechanical advantage is greater than 1. For example, if its mechanical advantage was 2, the machine makes it twice as easy to lift as it would be to lift it without the machine. If the mechanical advantage is less than 1, it's harder to lift. For example, 0.5 would mean it's half as easy to lift using the machine as just lifting it without it. And finally, if the mechanical advantage is equal to 1, then it's equally as easy to lift the object using the machine as it is when you don't use the machine. So what good is a lever with a mechanical advantage of 1 when it's equally as hard to lift as it is to just pick it up? The advantage is a change in direction. You push down and the load goes up. Maybe this would keep you from hurting your back. Remember free, F-R-E. Fulcrum, resistance, effort. So the resistance, the load, needs to be in the middle on a second-class lever. Get your pencil, put your load or resistance in the middle, and put your hand at one end to be the fulcrum. Then your effort will actually lift up rather than down. So sketch that with an arrow pointing up rather than down on this lever. Then move the effort force closer to the fulcrum, but don't go past the load, and move it further away from the fulcrum. And then move the load closer to and further away from the fulcrum. If it's easier to lift, the mechanical advantage is greater than 1. If it's harder to lift, the mechanical advantage is less than 1. All right, F-R-E, E, effort. Effort must go in the middle for your third-class lever. So that means you will lift in the middle, which means your fulcrum's on one end and your load's on the other. You lift in the center of the pencil. Then move your effort force closer to and further from the fulcrum and answer the questions on your paper. Since you are lifting up, be sure to draw your arrow upwards on the third class lever sketch. Finally, answer the questions on the last page.